So in this video, we'll be discussing the another thing, that is an optocoupler. So optocoupler can also be used in our embedded system, which helps in isolating the two modules. Okay, why we need to isolate? First of all, why we need to isolate is, I'll just show you. See, the optocoupler will be having the two important elements, that is an LED as well as a phototransistor. So LED will be emitting the diode, and the phototransistor will be having the ability to detect the light that is being emitted by the LED, right? And again, why we need to isolate the two modules or the two circuitry is, so this particular part, okay, so this is the first circuitry and this is the second circuitry. So the first circuitry may be working with the highest voltage and the second circuitry may be working with the moderate voltage. So whenever I am trying to connect the first circuitry to the second circuitry with the physical wire, okay, with a physical wire without any isolation, then the first circuitry, which is operating at a higher voltage, may damage some of the elements or the components that are present in the second circuitry. So therefore, in order to avoid such damages, the isolation is created, and of course the information from the first circuitry to the second circuitry is also taken with the help of a concept called as an optocoupler, or the devices called optocouplers. So what actually the main thing that we are doing is, so here the signals are passed in the form of a light. So here we are coupling the two circuitries or the two modules with the help of a light, and the light is emitted from the first circuitry component and the light is detected by the second circuitry component, that is a phototransistor. So now, in an electronic circuit, an optocoupler is used for suppressing interference in data communication, circuit isolation, high voltage separation, simultaneous separation, and signal intensification. So that is what I was explaining with a simple example, high voltage separation. Optocouplers can be used in either input circuits or it can be used in the output circuits. Okay, so optocouplers is available as in the form of ICs from the different semiconductor companies. So this is one such example that it is there in your syllabus, where optocouplers is used both at the input side as well as the output side. So this optocoupler is used at the input side and this optocoupler is used at the output side. So if you just observe here, so optocouplers, whenever I'm using the LEDs at the input side, I'll just try to show. So we are giving the information from this part to this part. We are giving the information from this part to this part with an isolation, but how the information is being circulated or it is transmitted is with the help of a light. So once the phototransistor is detected, so it will be providing a necessary control signals to the microcontroller and necessary operations will be performed, and we are not bothered what necessary actions or operations are used here. And of course we can also use the optocoupler at the another end, that is output. We can also use the optocoupler at the output side as well. So if you want to transmit any information from the microcontroller to this particular circuitry, then you can also give the information in the form of a light to this circuitry, and those light in on the low, that light will be captured by this phototransistor and therefore it will be working accordingly, right? So therefore this diagram will illustrate or tells the optocouplers can be used both at the input and output circuit.